as we're taking a peek in here, we've talked about all these different forms that your lines can take, but most of the time, they're going to come back into slope-intercept form more often than not. So our first one that we're going to take a peek today here at in the practice is dealing with some of the application stuff. Now, we've learned we need to look for some keywords when it comes to this. So we're like, all right, Haruki, $20 in a savings account, it's just 20 bucks sitting there, and is adding $5 every week to his savings. So this is something that's variable. Depending on how many weeks there are, it's going to be an extra $5. So there's the place that we're looking with our variable. Oh, except I needed to read forward myself. The amount of money after W weeks. All right. So write an equation to represent the amount of money savings after W weeks. Okay, so there was our variable. So you could write it either way. I'm a bigger fan of writing it this way because it looks more like slope-intercept form would. Okay, where you have the variable term and then the constant. And so for me to complete the table, that X is my W. If you just wanted to use X, that's okay. Bless you. And so here, we're just going to plug in. If you want to use the calculator, you could. But, so let's see here. So this is going to be my 5W plus 20. So 5 times 0 is 0. Plus 20 is 20. And I'm just going to keep plugging that 1 in. So 1 times 5, so we got 5 plus 20. Times 2, we got 10 plus 20. And at this point, maybe I'm seeing a pattern develop here. It just keeps going up by 5 each time. Kind of like my slope does. So same type of idea. And so fortunately for us, there's already a grid made. Savings, weeks, everything here on our X and Y axis. So again, just in case, never hurts to label. These are all coordinate points. So it just means my X is 0, is 20. My X is 1, my Y is 25. And so if I'm graphing, I get those values. And that would just keep going. Now, this is not like an inequality at this point. We're not doing any shading. This is just exactly how much Haruki would have. So, what does the y-intercept represent? All right, so let's see here. That occurs when x equals 0. So that's this point right here. So 0 and 20. How might I be able to explain to somebody what that point actually means? At 0 weeks, I'm at the beginning. This is when I'm starting what I'm doing. So at 0 weeks, I have 20 bucks. Oh, Haruki had 20 bucks in the savings account, then started adding money. So this could be beginning of Haruki saving. You could even say just that's how much money you started with, if you wanted to make it a little bit more concise. And so we basically would be able to just keep this pattern going to figure out other information. So, okay, when will there be $40 in savings? I think this one we can hammer out pretty quick. How many weeks is it going to be before Haruki's to 40? You're close. Okay, so if I were to kind of just extend this even one more and just keep adding 5, I could do it that way. If I looked at how my graph got extended and say, hey, there's the 40, there's my 4, got another option. Now, I don't think the graph might help us as much on this next one, though. How much money is he going to have in 20 weeks? What's a way I could go after that? Because the graph is not going to be big enough for me. What's that 20 represent in my little equation here? My weeks. So could I just replace the W with 20 and then go ahead and plug that in to find the value? So sometimes putting something in slope-intercept form, it may not even be about the graph. Like there, the graph didn't really help me, but having that little mini expression let me just do a little bit of substitution and stretch it out to where I needed it. You know, maybe Haruki was working on saving towards a special item or something like that. And now I can say, okay, it's going to take me, oofda, it's going to take me, you know, about 5 months here to get there. Everybody's got their own thing here. So just a couple of things to ponder. This last part, and I just want to check one thing before I get going here. Yep, we're going to want to do one of those. Okay, one of these and one of those, and then we're set. So answer the questions for each graphed application. Okay, so remember, rate of change is just a fancy way of saying slope. So what I can do here is I want to make sure my rate of change, I got to have 2 coordinate points because I need 2 x values and I need 2 y values. And so luckily for me, I'm not going to have to go looking for points. They literally have the dots on here for me. So I can pick any 2 of these that I want. So let's just decide I'm going to use the first 2. So I've got, let's see. So x value is 5. Y value is right between 60 and 80. So that'd be 70. And if I use the next one too, I've got 10 and 90. So now I'm going to take those, and it does not matter which one you make x1, y1, x2, y2, but you got to be consistent. So if I make these, this x1, I got to do that with y, and so forth. So let's see. So y2 minus y1 over x2 minus x1. If you're going to go to the calculator, you're going to try and do this all at once. You've got to have parentheses around your numerator and denominator. Otherwise, just put them in separate, and we can do it that way. Okay, so my rate of change, my slope, is 4, and that always goes in front. Did I do something crazy? Oh, I might have. I never put myself past doing something crazy. Let me make sure here. 20, 10, and 5. I think we're okay. Now, my y-intercept. Here's my y-axis. Where are we crossing? Bless you. My y-intercept is 50. And we're just going to steal that right off the chart. And that's all we need. So that's how I can kind of work things backwards. Let's say somebody handed me a chart for a business that I was working on and said, okay, here's how the cost in people and this whole margin goes. I need to be able to expand this, though, to something bigger, like over a year or over 5 years. Can you come up with the equation? This is where you can take the data and extrapolate it backwards. And now I can do this for any amount of time. I can do it for any amount of people. Hey, if our workforce went to 100 people, you know, what would the cost be to do that? And I could start to figure those things out. So it's kind of a cool thing to let us work through some of that. Let's see how this goes. Okay, I think, I just want to make sure. Yep, that's the other one I want to do. So one more flip. And then we're going to start taking a peek at this little thing with all the little squares here. All right, an internet provider charges $18 per month plus an initial setup fee. There's that per month thing again. So we've got 18x. Plus an initial setup fee. Well, we don't know what that is this time. Normally that's our plain number. We're going to have to figure something out here. One customer paid a total of $81 after 2 months of service. Okay, so we know a couple things. Our X this time is going to be the number of months that we're paying for this internet service. So, how am I going to get this figured out? So it says write an equation in point slope form, modeling this situation. So I'm just going to put point slope form down here. We'll work over here. See, sometimes depending on the information that we have, we've got to make a little bit of an adjustment on how we're going to go after it. We may not be able to go to slope intercept right away every time. So, let's see here. So to do point slope, I need those three values. So let's see if we can figure this out. Okay, let's see. $18 per month, that sounds like my M. So we know that 18 is going to be there. This X and the first Y never change. So we're hoping that we can figure out the rest of this. So here's the thing. Hardy, I got 81 and I have 2. They've got to go in these 2 slots, and you're right. So here's what I got to think about a bit. And this might help me. I know it seems strange because it's a different question, but for a minute, just a minute, I'm going to flip back here for a minute. And I'm just going to start looking, and I'm going to go, So days and dollars, dollars and people, cost and number, weeks and say. You notice how I keep seeing that all of the money things always seem to be on the y-axis. So if that's true, here's my money. So the money is going to go with my y's because that's where money seems to go. Time seems to go with x. So sometimes referencing my other problems can help me to work through this one. So now I've got enough info. What's the initial setup fee? We got to get into y equals. So if you saw the lesson yesterday, you'd know, and we're in point slope, if we want to get to slope intercept, we got to do a little distributing on this other side. And my last job, since I want it in y equals, would be to get that 81 out of there. Now, is the equation the only thing I need here? No. It gives me the answer I need, though. $18 a month, that's right here, plus the initial setup fee. Oh, the plain number. My setup fee was $45. They didn't tell me that. I was able to figure that out by plugging in the other information I had since they didn't give it to me right away. And so now all I'm going to do to finish this up, how much does it cost after 5 months of service? If I plug in 5 for X, oh, am I going to trust my brain? I think I'm going to. 90, 45. Not too shabby. Not too shabby at all. And I will say this as well. Even though we've got a fully worked out key, but if you're just kind of wanting an idea if you're on the right track, at the bottom of this page, for this whole worksheet, the answers are all there. They're just all mixed up. So if you want to double check something right away and not just look at the answer, because you're going to be tempted to copy, that's not a bad option in working through as we're doing these. Okay. So we'll play with finishing that up a little bit here as well. Now, the last part I'm going to show you again. I don't have to have this last part until we get, to our quiz next week. But I did want to show you what this would look like and a couple of hints I would give, because I've done one myself already. So the last piece of the puzzle is going to be this little group of squares that you got. There's 12 of them here. So the initial thing I would suggest doing is taking the blank piece of paper that was back there that you got. I would square this off into like 12 squares. And I'm not going to put these on here in the right order because that would be kind of silly and ridiculous. So, oh dear. Now my dot camera's going crazy. Okay. So I'm kind of looking, and I would consider going, all right, if I put all 12 of these on here at the start, and again, I know there are some issues that I saw when I came in this morning with the clips on how the sides have been, some of my sides have been obliterated. So, lesson learned. Sometimes you got to do things yourself. Now, don't put them all on like I am right now currently, but it's just going to kind of let you see when you get to the end, you're going to have something like this. So whether you want to use tape at some point, the glue I have in the back, just kind of make sure you're in good shape. Or, since there's 12 squares, let me show you one other thing I'd consider, because this is what I did when I did it the first time. I'm going to try going out on this. Dang, I can't go out anymore? All right. I went ahead and I split this. So I went like this. I did it twice. You'll see the method to the Hardy Madness here in a minute. So there's my 4. And then I folded these in. Now this is kind of a science, not an art. I did the envelope fold the other 2 ways. So I ended up with 12 boxes on my paper. And then what I did was I took a pencil, and as I started to work, and I'm like, oh, that's working, that's working. I kept writing the letters in the boxes instead of trying to keep them on here, and then the wind comes by or something blows, and there they go. And I'm like, no, not all the work I just did. So you're like, okay, so how do these work? So on each of the squares, not always on all the sides, but on some, there's different information. It might be something in slope-intercept form. It might be just giving you the slope and the y-intercept. It may be a point and slope. The idea is there's another box with another edge somewhere that has that information on it. So like my strategy was when I looked, these were the ones I was looking for right away. These are going to be the easiest ones to deal with. Because if you gave me the slope and the y-intercept, I'm looking for something that has a slope of -1 and a y-intercept of 1. And when I find it, slope of -1, y-intercept of -1, I know those two go together. Now, do they go together on the right? I don't know. Do they go together over here? Down here? I don't know yet. That's why I'm going to use a pencil on everything, because I'm like, this could get to be a little bit interesting if I don't. But then I was just build from it. Ooh, slope is 2 and y-intercept is 3. Okay, let's see here. Now here's the thing though with that. Okay, I found one. Sometimes the form may change. They may be in standard form. I don't think any of these, none of these are in point slope form. But I can kind of keep playing because again, sometimes I'm just going to get to a point where I got to do some work. So I'm like, all right, let me find one where I got to do some work. So I see this one. I'm like, ooh, m equals 3. Got to do a little side work here. Then I will stop harassing and let you kind of play. I'll jump back in if I need to. So I'm like, all right, well, if they give me the point and the slope, and you can write on these, shoot, I got to do point slope. So I'm going to do y minus y1 well, minus a negative is plus, equals m x minus x1. So we're not going to be able to avoid doing some sort of work on these. 1/3 of 3 is 1. That's why we're going to give you plenty of time on this. So now I got to go searching. And I'm searching currently. Haha. Now here's the cool thing. I haven't done any work on this one. This looks good because the slopes are the same and they just went together from me doing another one. Now, does that mean for sure I'm right? Might I want to plug this into point slope just to be sure? Maybe. But otherwise, I might just assume that that one's right and then just kind of keep going. So maybe I jot in the corner of my paper, okay, G, A, L, and H. They're going to make a little square somewhere here. Here's the other hint I'll give you. Some of these you're going to start to find have blanks on an edge. That's going to mean that's got to be on the edge of your paper because there's nothing to connect it to over here. So now I've even figured out that's the right side. It might be up here. It might be down here. I don't know. I kind of do, but I'm not going to say. And I can start to keep building off of those corners. But keep looking for the easy stuff. I'd do that one next. Or maybe I'd do one of these where I got to find the slope first and keep working with those. This is another one of those, though. If you get stuck somewhere, plenty of time to be able to ask me a question today, tomorrow, early next week, something like that. But I'd keep making little marks on my paper, maybe like behind this, put like G, A, L, H, and then if we got to move things around, we will a little bit.